Right, so now we are going to look at the oxidizing action of halogens, or how these halogens act as oxidizing agents. So I have the guiding questions there. I'll state what would be observed and explain your observations when chlorine and bromine are separately added to an 3 chloride solution. Yeah. Okay. So that is our question. If we add chlorine and bromine to iron 2 chloride solution separately, since both oxidizing agents, okay, iron 2 chloride solution, iron 2 compounds are green. So we expect this iron 2 to be oxidized to iron 3. Iron 3 is brown. So the observation would be in part 1 that a green solution turns brown. That is in each case. In each case, the green solution turns brown. Right, so explain your observation here. You need to first show me how chlorine and bromine are oxidizing agents. So the explanation would be chlorine and bromine oxidize iron 2 ions from iron 2 chloride solution. So we have iron 2 ions to iron 3 ions. Okay. These oxidizing agents, for them, they get reduced. So if chlorine and bromine oxidize iron 2 ions to iron 3 ions, for them, they are reduced to chloride ions and the bromide ions. So chlorine and bromine oxidize iron 2 ions to iron 3 ions as they are reduced to chloride ions and bromide ions respectively. For them, they are reduced to these respective ions, the chloride and the bromide. So you have to demonstrate that using an equation. Iron 2 ions react with the chlorine gas. They get oxidized to iron 3 and the chlorine gas gets reduced to chloride ion. That is it. For the case of the bromine, the same. So iron 2 bromine is a liquid, oxidizes it to iron 3, and the bromine is reduced to bromide. Or can write iron 2 chloride solution reacting with chlorine gas, and the Iron 2 is oxidized to iron 3. Is that true? So that is what we found. So that is the part 1. Part 1 is covered. The green solution of iron 2 chloride turns brown. It goes to iron 3. Then now you talk about how oxidizing these are, chlorine and bromine. And what are they oxidizing? Iron 2 to iron 3. For them, when they oxidize, they get reduced to chloride ions and bromide ions. Then you write the equations. Then here, chlorine is bubbled through potassium nitrate solution. Chlorine is bubbled through potassium nitrate solution. Of course, for this particular case, you realize that chlorine, the chlorine gas will dissolve. Yeah, the chlorine gas will dissolve. And you form a colorless solution. Rather, the colorless solution will form a precipitate. That will be the formation of a precipitate, which is silver chloride, because the chloride ions formed will react with the silver. React with silver ions from silver nitrate, forms silver chloride, which is a precipitate. But then when that silver chloride reacts with excess ammonia, we form a soluble complex of diamine and silver 1 ion. So let's see, they're saying that chlorine is bubbled through potassium nitrate, right? So the equations will guide us, but still, since chlorine is a greenish yellow gas, so we shall say a greenish yellow gas dissolves, and the colorless solution, okay, and the colorless solution formed a white precipitate, which white precipitate dissolves in excess ammonia to form a colorless solution. Then we see the stages by equation. So the observations for part 2 would be greenish yellow gas dissolves, and the colorless solution formed a white precipitate which is soluble in excess ammonia to form a colorless solution. From a colorless solution. Then explanation, because they said we state observation and then we explain. So the explanation would be chlorine, being an oxidizing agent, oxidizes the nitrate ions to nitrate ions, and itself reduced to chloride ions. So this reaction is, we have a nitrate, but that it takes place in presence of water plus chloride or chlorine gas. We see that a nitrate is oxidized to a nitrate and the chloride is reduced to, rather chlorine is reduced to chloride. Shall have a 2 here, then shall have 2 hydrogen ions. Now, these chloride ions formed, they react with the silver, form silver chloride. So we shall say silver ions from where? From silver nitrate, right? Silver ions react with the chloride ions. These chloride ions to form insoluble silver chloride. When we write the equation, we shall have silver ions plus chloride ions to precipitate silver chloride. Now, this silver chloride reacts with excess ammonia to form a soluble complex of diamine silver 1 ion, which is colorless. So the whole mechanism begins with getting a chloride, which reacts with the silver from silver nitrate, from a silver chloride, which reacts with the excess ammonia. So we shall have silver chloride solid plus excess ammonia, which is excess ammonia. We write excess ammonia molecules to form a diamine silver. If we say diamine, it means that we have 2 diamine silver 1 ion and chloride ion. So that is the observation and the explanation. Right. Okay, for this case, we can have some other question. Also, chlorine gas was bubbled through sodium sulfide solution and to the resultant solution was added barium nitrate solution. State what was observed and explain your answer. State what was observed and explain your answer. For this case, The observation would be this chlorine gas, which is greenish yellow, dissolved. And then the colorless solution, of course, from the white precipitate with barium nitrate, which we can see the equation. So since we have sodium sulfide, it means that chlorine oxidized sulfite ions to sulfate ions that combine with the barium ions from barium nitrate form barium sulfate, which is a precipitate. So the observation would be greenish yellow gas dissolved. The greenish yellow gas is chlorine. Dissolved and the colorless solution formed a white precipitate with barium nitrate solution. Barium nitrate solution. Then the explanation behind this chlorine, being an oxidizing agent, oxidizes sulfite ions to sulfate. And itself reduced to chloride ions, and itself reduced to chloride ions. Now, for this case, we have formed sulfate ions. So these sulfate ions are the ones that will combine with barium ions from barium nitrate to form barium sulfate. But here you can first write the equation. Sulfite ions in presence of water act with chlorine form sulfate ions hydrogen ions and chloride ions. Then that the barium ions react with the sulfate ions form insoluble barium sulfate, form insoluble barium sulfate, whereby the barium ions from barium nitrate react with the sulfate ions, which are got from oxidizing sulfite, form barium sulfate, which is a precipitate. As simple as that. So that is how the reaction takes place. Reaction takes place. So now, another equation or another question can be chlorine gas was bubbled through potassium manganate 6, potassium manganate 6 solution, and the resultant solution was added dilute sulfuric acid dilute sulfuric acid and tin 2 sulfate solution. State what was observed explain your answer. State what observed and then explain your answer. Okay, now looking at this question, we need first to know that in this case also a green yellow gas will dissolve. Then the green solution, okay, the green solution of manganate 6 turned into a purple solution of manganate 7, which then turned colorless on treatment with the tin. All right, so that is what we are going to discuss. So the observation would be greenish yellow gas dissolved, and the green solution turned purple, all right, and then colorless. Dissolved, green solution turned purple, and then colorless. Now, the explanation would be chlorine oxidized manganate 6 ions to manganate 7 ions. To manganate 7 ions, and it's off reduced to chloride ions, and it's off reduced to chloride ions. So the equation would be manganate, potassium manganate 6, so it would be manganate ions from potassium manganate 6, then plus chlorine gas. This will be oxidized to manganate 7. So from manganate 7 and 2 chloride ions. Or one can say potassium manganate 6 plus chlorine gas to form potassium permanganate or potassium manganate 7 and potassium chloride. Now, this potassium permanganate, it then oxidizes because it's an oxidizing agent. It will oxidize tin2 ions to tin4 ions as they also reduce to manganese 2 ions. So you come and tell me that the acidified manganate ions, because was added sulfuric acid, so the manganate ions now are acidified. Acidified manganate, the acidified manganate 7 ions oxidize tin2 because they added tin2 sulfate, so we have tin2 ions to tin4 ions, and itself reduced to manganese 2 ions. The equation for that would be the acidified manganate, so since it's acidified, 16 nitrogen ions plus 5 tin2 ions, we form 2 manganese ions plus shall form tin2 will be oxidized to tin4 and 8 molecules of water. This is a redox. This is a redox. The permanganate ions are oxidizing agent, so they are oxidized to, rather they are reduced to manganese 2 and water. All the tin is a reducing agent which is oxidized to from tin2 to tin4. So on combination of these two, there is a YouTube video that I recorded on this the redox reaction. So that one can guide you on how to write redox equations. So you first write the half equation of manganate 7 ions acting as oxidizing agents as they are reduced to manganese 2 and water. Then you also write another half equation to show the reducing action of tin2. Tin2 are reducing agents, and therefore for them they oxidize to tin4. Then you combine the two. On combination, you come up with this. There's a section, and there is a section I recorded. Okay, there is a section I recorded as a guide on writing the redox reactions. It can help everyone understand the concepts very, very, very well. Then from there, we shall have a look at still oxidizing action. Describe the reaction of chlorine, bromine, and iodine with a sodium thiosulfate solution hydrogen sulfide then sulfurous acid. We shall have very many other questions done under this part. So with this, we can really see how it does. We can really see how it does react, how those elements react with how those elements react with how they react with those other compounds. Well, okay. Let's begin with sodium thiosulfate. For the first part, you can see already we know chlorine, bromine, and iodine are oxidizing agents. So now we really need to see how they react with the sodium thiosulfate first. Now, the two, chlorine and bromine, will oxidize in thiosulfate ions to sulfate ions. Okay? So we shall have chlorine and bromine oxidize thiosulfate ions to sulfate ions, and they are reduced, or as they are reduced to, of course, chloride ions and bromide ions respectively. So we have equation thiosulfate ions being oxidized by chlorine in presence of water to form sulfate ions, hydrogen ions, and chloride ions. The same applies to bromine. That is it. Bromine is a liquid, not a gas, so we form sulfate, hydrogen ions, and that now, the exception is that if we use limited chlorine, however, if limited chlorine is used, the thiosulfate ions instead disproportionate to sulfate ions. Is a very common equation to sulfate ions, sulfur and chlorine, is reduced to chloride ions. That's what you need to know. So if we use limited chlorine, the thiosulfate ions go to sulfate. The oxidation takes place still, but we form sulfur now. In this case, we shall form sulfur also amongst the product. So the equation would be thiosulfate ions plus chlorine gas and water the sulfide will be oxidized to sulfate plus sulfur and the hydrogen ions, and then chloride ions. So it goes here. That is if at all the chlorine is limited. But iodine, for the case of iodine, is it's an oxidizing agent, but a weaker one. So it's a weaker oxidizing agent. All right, so it oxidizes thiosulfate ions. Thiosulfate ions to tetrathionate, to tetrathionate ions, and itself reduced to iodide ions. Now, being a weaker oxidizing agent, it oxidizes a thiosulfate to tetrathionate, and so goes to iodide ions. The equation would be iodine H2 plus thiosulfate H2O3 to form tetrathionate. It is AC4O6 2 minus, and then iodide. That is what we have. So that is how those three react with sodium thiosulfate ions. Okay, from this, we shall also look at the reaction with hydrogen sulfide. Reaction with hydrogen sulfide. For the case of hydrogen sulfide, Okay. Chlorine and bromine they oxidize. Chlorine, there is also iodine. And iodine oxidize hydrogen sulfide to sulfur, which is a yellow deposit or a yellow solid, to sulfur, as they are reduced to, if it is chlorine, to form hydrates, to hydrogen chloride, hydrogen bromide, and hydrogen iodide respectively. So the equation would be chlorine gas plus hydrogen sulfide be oxidized to sulfur, and chlorine will be reduced to hydrogen chloride. These are hydrates of group 7 elements. So then chlorine, rather bromine also, being a liquid, hydrogen sulfide gas to sulfur still, then plus hydrogen bromide. Still iodine for it is a solid, oxidizes hydrogen sulfide gas, precipitate sulfur, not form a deposit of sulfur, sorry, and hydrogen iodide. So that is it. Then the last part is the reaction with the sulfurous acid. Chlorine and bromine do oxidize sulfurous acid, sulfuric acid, and itself reduced to hydrochloric acid and hydrobromic acid, respectively. Equations is that chlorine gas in presence of water, oxidize sulfurous acid to sulfuric acid, and itself reduced to hydrochloric acid, HCl. Then for the case of bromine, to be bromine liquid in presence of water, oxidize sulfurous acid to form sulfuric acid, and itself reduced to hydrogen, rather hydrobromic acid. So that covers the reactions of group 7 elements, and our next lesson shall be hydrates of these elements. So we shall look at hydrates of group 7 elements. All right.